Hi class. So today I'm going to go ahead and go over a quick example that's going to look identical to your written assignment for Module 4. Okay, Part 1 and Part 2 tend to get a lot of people with this question as they are a little confused of what is being asked. So really make sure you follow along with this as I'm going to go through all parts of this written assignment. Again, if you have questions, feel free to reach out. And then again, I always have those office hours Sundays from 1 to 2. And if that time doesn't work, just email me and we can set something else up. Okay, really fast though, the live lecture question for this week is, what is currently your favorite TV show and why? Okay, so what show do you think I should be watching in my free time? Okay, so again, live lecture question, module 4 is going to be, what do you think, or what is your favorite TV show and why? Okay, so let's go ahead and get this question started. So here's the picture again. All I'm doing is changing the numbers. Everything else is going to be identical. So the question says, this question here, so you are going to plant a rectangular flower bed consisting of tulips in the middle, surrounded by daisies on the outside. You have the same amount of each flower and will need an equal area for each. You want the border of daisies to be uniform around the tulips in the middle as shown in this diagram. Okay. So again, think about this. Here we have the tulips are in the middle, daisies are on the outside. And they're going to be equal. Part 1, find the total area of the flower bed. Okay, well, one thing we can think about is we know that the tulips and the daisies are going to be the exact same size. Remember, area, so this is a rectangle. So your area of a rectangle is always the length times the width. Well, I know I can see the area of the tulips. So the area of the tulips is going to be 6 times 4. So we have 24 square feet. So that's the area of the tulips. But again, they're asking us for the total area of the flower bed. So again, since the daisies use that same area, we know we can just times it by 2. So 24 times 2 is 48. So the total area of the flower bed is going to be 48 feet squared. So make sure you get the correct label there. So that's all I'm looking for part 1. Let's go ahead then and move to part 2. So part 2, this is write the area of the flower bed as an equation using multiplication of 2 binomials. So remember, a binomial is a polynomial that has 2 terms. So what we're going to do is, this is how we're going to go back. I'm going to just go here. This is why we're using this x now, okay? Because I got to be able to write this formula. So we have this is x and this is x here. So I want to do the length of the whole thing. So if you think about it, and I'm going to use a different color now. I like this green, it's nice and bright. So the length is here, all the way through here, and then here too. So remember, this is going to be equal. So if you need to think about it, this is also x, and this is also x, because these are equal rectangles. Okay, so now we're going to go ahead and use that to write our first formula here. So the length of this is going to be x plus 6, oops, I meant to be a plus x, okay, which is the same thing as 6 plus 2x. So that's the length of the width, of the length, sorry. Now we're going to go ahead and find the width. Okay, so again, same idea here. I'll do this one in blue. The width is this length of this thing right here. Well, again, think about it. This is x. Well, if this is x, this is also x. So we're going to add this up. So it's x plus 4 plus x. I'm going to go ahead and write this over here now. So this is equal to x plus 4 plus x. And then combining my terms, I get 4 plus 2x. Okay, so that's the length, that's the width. Now remember, we want to write the area. Area, again, is going to be length times width. So we're going to go ahead and plug that in. So the area is equal to the length, which is 6 plus 2x, times 4 plus 2x. Now the only thing though is we have to be able to solve it. We do know the area of this whole thing. So the area, and again, that's what we got from part 1. Okay, the area was right here. That's 48. So now I'm going to put in 48 for this. So this is all I need to do for part 2, as part 2 is just asking me to write the area formula. So again, area of a rectangle is length times width. We found the length, we found the width, and then we just plugged them in. Okay, so it's 6 plus 2x times 4 plus 2x equals 48. So part 3 is where it can get a lot of people because this is where we have to solve it. Okay, let's go ahead here. So I'm going to bring this equation down. So I have 6 plus 2x times 4 plus 2x equals 48. First thing I'm going to do now is I'm going to distribute. Ooh, that changed color. Okay, there we go. Well, 6 times 4 is 24. And then 6 times 2x, so plus 12x. Now I'm going to distribute here. 2x times 4 is 8x. And 2x times 2x is 4x squared. And again, this is all equal to 48. Okay, so now we need to solve. So remember, the first thing I'm going to do when solving is we want to combine those like terms. So here are my like terms here. And just because this is a quadratic, I'm going to move this to the front. So that's 4x squared plus 20x plus 24 equals 48. Okay, so the first thing I do when I solve, I need to use that zero product property. That means that on the right side, so this right here, we got to have that equal to 0 to solve. Because again, when you're solving a quadratic, which is a parabola, and we're going to get to the more of that in the next unit, it's where your solutions are always where x is going to be 0, so on that x-intercept. So that's why it has to be 0. So I'm going to go ahead and subtract 48. Again, what you do to one side, you do to the other. So now I have 4x squared plus 20x minus 24 equals 0. And I'm running out of room, so I'm just going to go ahead and add another page to that. I'm going to go ahead and copy this. So that, again, that was 4x squared plus 20x minus 24 equals 0. So now I need to factor this. Well, remember, the first rule with factoring is you always are going to look for that GCF. So again, I'm looking here at the numbers. So I have 4, 24, and 20. Well, I always look at the smallest number, 4. Can 4 go into 20 and 24? Well, it sure can. So I'm going to factor out a 4. So then 4 divided by 4 is 1. You can put 1x squared or just x squared. Bring down the plus. 20 divided by 4 is 5. And negative 24 divided by 4 is negative 6. Okay, just going to double check inside that parentheses, 1, 5, and 6. They do not have anything in common besides 1. And then we have x squared x and no x, so we can't take any x's out there. So we factored by our GCF. Now I'm going to go ahead and look in here and see if this can be factored. Well, first thing I notice is our c value is negative. So I'm going to set up those parentheses. So I have 4, so that's x plus, x minus. And if you're not sure what I'm talking about here, go back and watch some of those small videos. But the reason why we do a plus and a minus, think about multiplication. The only way to get a negative number is when you multiply a positive times a negative. So that's why these signs have to be different. Okay, so now we got to figure out what number goes here. Well, I need factors of 6 that when I subtract, give me 5. Okay, well, so again, you can go factors of 6. Well, my factors of 6 are 2 and 3 and 1 and 6. And since this is negative, we're doing subtraction. Well, 3 minus 2 is 1, so that doesn't work. 6 minus 1 is 5, so we have a winner. And now we just need to see what order it goes in. Is it going to be 1 minus 6 or 6 minus 1? So you look at the sign, that's a positive. So then I know it's going to be 6 minus 1. Perfect. Okay, so now we're going to solve. So now again, remember, well, this is where we set them each equal to 0. What color do I want to use? That one. Okay. Well, you could put 4 equals 0 here, and then you have x plus 6 equals 0, x minus 1 equals 0. Now, this isn't a true statement, so you don't actually have to do anything with that. If there was an x next to it, you would have to solve for it, but there's not, so you really don't have to write that one right there. Okay, so now we need to solve for x. Well, I'm going to subtract 6. X is equal to negative 6. Now I'm going to add 1. X is equal to 1. So these are my two solutions for part 3. So you have to show both. You have to show all this work to get credit for this, okay? So x is equal to negative 6 and x is equal to 1. And just an FYI, I am doing the problem that is out on the internet, so you cannot submit this one. Okay, this is why I'm doing this one, because I already know it's out online. This is why I changed the numbers. But again, I'm changing the numbers. The concepts are the exact same. Okay, so we got part 3 done. Now let's go ahead and go to part 4. So part 4 is asking us to identify any extraneous solutions. So our extraneous solutions, very simply, are answers that don't make sense to this problem, okay? Well, let's look at this problem. And I'm just going to go ahead and put this up here. So we know we got x is negative 6 and x is 1 as our two answers. Well, this is what x is representing. It's representing this length right here. So I want to ask you this. Can a length be negative? Can I have a negative length? The answer is no. No, we cannot have a negative length. So for part 4, that means, so since that answer doesn't make sense in the real world, that is our extraneous solution. So again, I need to make sure I'm answering this question. You can't just put x equals negative 6, okay? You have to tell me why. Okay? So formally, I would just rewrite it like this. So the extraneous solution is x equals negative 6 because we can't have a negative length. Okay, so that's going to get me full credit on this problem. So tell me what it is and tell me why. Last part. It says find the width of the part of the flower bed with the daisies. So this one always, I think, can be interpreted a little bit differently, and I do take 2 different answers on this one, okay? So again, we're going to go back. So I want the width of the flower bed. That's just the daisies. So here is just the width right here, and again, that's represented by x. So the width of the daisies is here. So then the width, okay, and here's the thing. This could also, some people are like, well, the width could be here. They're both x. So in this case, and then some people also, so the answer could be 1. So it is 1 feet, okay? But also people are like, well, here's also, this is whole thing, because this area represents the daisies. So I'll be honest with you, I will take both answers. You can give me x is 1. You could also give me 6 here as well. And how did I get that? Remember, x is 1. 4 plus 1 plus 1. Honestly, I will take both answers for that. But technically what we're looking for is just this width right here. So that is 1. Okay? So x is equal to 1. So again, then how I'm going to write it, the width of the part of the flower bed with daisies is 1 foot. Okay, so that's my formal answer right here. Okay, so that is how you do the written assignment. Let me know if you have any questions, and I'm really sorry I could not be joining today. I just had a family emergency come up and I have to leave town. Nothing major, just have to go. But this is how you do the question. I will be available for office hours tomorrow if you have any more questions. Have a great day.